Hello, we're Team Gray. Today we're going to talk about the Olympic data assembly. Here's our goals. Since the datasets are from different sources, the name of the disciplines and athletes might be different. In order to make the future analysis work, we first organize data in a way that similar titles will be considered as the same. Second, with organized datasets, we next would like to know how much influence there is for the countries that host the events. Third, we also would like to know the intensity of competition over specific disciplines between countries. And now I'm going to introduce a little bit about the datasets. Medals 2021 and history both include 3 CSV files. First, athletes CSV and athlete events CSV, they both focus about the athletes themselves, their own information about their names, gender, and birthday, birthplaces. Medals total CSV and Summer Olympic medals CSV are focused more on how many medals does each country earn in each event. And medals CSV focus on who does each medal belongs to, specifically on the aspect of athletes. And last, we have NOC regions that indicate the NOC of all the countries. And next, we'll talk about ERD.
Here's our ERD for the project. As you can see, we have 4 entities: athletes, game, discipline, and nation. Relationships in the ERD is a little bit complex. First, athletes represents nation and nation hosts game. Game features discipline means they set this discipline in one particular year's game. Between athletes and the integration of game and discipline, we have 2 relationships, attend and result. Attend only stores who attend which discipline in which year's game without their final result. And result stores every medal obtained by athletes. This design allows us to deal with less rows when we only want to search among the medal winners. At last, medal rank is obvious, recording the whole medal count of each nation. Here is a sample of our DDL. So first, we create a table, and then we insert the athlete information from the historical dataset, and at last, we insert from the Tokyo 2021 dataset. However, there are 2 major challenges we met during data preprocessing. First, we have unified athlete name. Take legendary gymnastic athlete Oksana Chusovitina as an example. Her name is in different format in different datasets. To solve this problem, we create a function named 2021 history and process all the names in the 2021 dataset to the format with first name first and first letter capital. The second challenge is to match up event names. Here are several samples of our different event names in these 2 datasets. We notice that the discrepancy lies in both word expression and word order, which is no longer trivial as we saw in the athlete name case. Fortunately, Postgre has something set for us. The trigram extension provided by Postgre will return a similarity score between 2 strings based on trigram comparison. As short, first it breaks the word into trigram sets, and then it compares the similarity or co-occurrence between these 2 trigram sets. This is how we use it. First, we create a desync view to store all trigram similarity scores between 2 event names. Then we set a threshold. If an event has another event that has a similarity score greater than this threshold, we deem this event as an existed one. After multiple trial runs, we decided that 0.65 is the best threshold in a coarse granularity.
Now, I'm going to talk about task 2 of our project, host influence. It indicates how much advantage does hosting event brought to the host country. For example, in the chart below, blue dots shows the number of medals China earned for all the Olympic events they have attended. And the red line is the trend of how many medals they expected to earn, exclude the year they are hosting. So, this purple line is the advantage we're looking for. Now, let's go over the techniques and challenges. First, We use linear regression to find out the slope and intercept so that we can calculate the expected number of medals they should earn. Next, we need to figure out a way to store an array of numbers into one variable because in our case, we need to store the years this country hosts the Olympics, and that is for the for each loop, another challenge we are facing. In the for each loop, we can find out the expected medals and extra medals the host country earned and compare them. And now, let's see some results. First, for the United States, it hosts Olympic Games for 4 times, in 1904, 1932, 1984, and 1996, and they earned 76, 41, 83, and 44 gold medals, but they expected to earn 25, 30, 38, and 39 gold medals. So the events helped it to earn 304%, 136%, 218%, and 112% gold medals as expected. Another example is China. China has hosted the Olympic game for only once, and they earned 48 gold medals, but they expected to earn 29 gold medals. So hosting the event helped China to earn 165% gold medals as expected. Overall, we can see that hosting the event gave host country more chance to earn medals.
Finally, our heads-up analysis. As we all know, US and China ranked among the top 2 medals all year round. Of course, there are some competition and also some friendships. But are they really have a fierce confrontation in some disciplines? We decide to come up with an index to answer that question. Here is how we calculate the index. Despite the math, there are 2 principles leading our calculation. First, if 2 numbers are both large, the index will be large, indicating the attendance. Second, if the gap between the 2 numbers is large, then intuitively there is little competition, so the index will be small. From the database perspective, we have this calculate index function to calculate the heads-up index between 2 nations in a particular year's game and in a certain discipline. We access the head-up intensity by taking the percent of male athletes, female athletes, male medal winners, and female medal winners into account. In the function, we just loop through arrays to put result into the return array. Then we just average the 4 value to come up with the final index. Here is a part of our results. We take the highest 3 and the lowest 3 heads-up index between the US and China in the Tokyo 2021 Olympics. As we can see, the 2 nations had a rather intense competition in disciplines like shooting and weightlifting, and they seem to seldom ran into each other in badminton, BMX, and basketball. This is an unlucky year for Chinese basketball. So that's our presentation, and thank you for watching.